Good afternoon. So I'm not going to take a lot of your time. Today we're going to talk about these HP, the dps-1200 SBAs. This part number here is the only thing we should care about. These last two digits in the part number mean a lot. A lot. So let's really pay attention. This part number is really important. I've been buying all of these from a guy off of eBay, and his screen name is Hopping Around. Hopping Around has made it very clear that if we buy from him, he's got them listed for $22 a piece or best offer for this particular part number. This one right here. dps-1200sb. You can buy these from all over the internet. There's hundreds of thousands and hundreds of thousands of these out there. So we're not going to run out of stock on these. Okay? And that's the reason I chose this particular power supply, because there's not so many of all the other versions. FB, the TB, the PDL, I think 33, whatever. I don't want to put a bunch of part numbers out there because it's going to get everybody confused. This is going to be a very straightforward, easy to understand video. Okay? dps-1200sb. That's what you put into eBay. Like literally the first person that pops up as a seller on eBay is Hopping Around. He's got them listed for $22 or best offer. Make him an offer, tell him BBI sent me for $19 and he'll sell them to you with free shipping. All right. Yesterday was unbelievable, the amount of phone calls I got with people asking me the same series of questions, and I get it now. I skipped over the most basic portions of this thing, or if I mentioned it, it was just very quick and very abrupt, and I don't think people caught it. That and the other thing I've noticed is people like to skip around in my videos a lot, and I kept getting the same question, but how do I do that? It's in the video. How do I do it? It's in the video. Did you watch the whole thing? Well, kinda. Watch the whole video. So let's be a little bit more clear about things. This is the resistor that you add from this post to this variable for voltage, and the one that's in the back is for the crowbar protection. In the first video, which I will tag and put in the comments in the doobly-doo, and also, or not in the comments, in the description. Also in the description, I will put a direct link from this video to the eBay seller with the part that you need, if you don't want to use Google to look this up for yourself. I assumed on my own that some of the stuff that I'm telling you right now, people would have just simply Googled it and figured it out on their own, but I was shocked with how many phone calls I got about this. Let's talk about how to set the power supply up and cover this one more time, because I did cover it in the first video. This potentiometer is what adjusts our either over voltage or crowbar protection. We set it so it's in the middle. This one here is what controls our voltage. When we add the resistor, we still are able to trim our voltage up and down by adjusting this potentiometer. It gives us 1 volt worth of variance. So when we add our resistor here, we still have to power on the switcher, power on the power supply, and adjust this trimmer to make sure our voltages are the same. That's going to come into play here in a minute. The other thing that I noticed, this blew my mind, because this come from another technician. And believe it or not, you guys, I got people that are all over the internet. So if you've got me blocked for whatever reason on Facebook or whatever, and you say some stupid shit, usually within minutes I start getting screenshots, because everybody and their brother's always willing to go start stuff. So let me read this out loud. I'm not going to say who this is from, because I'm not going to drag them on Front Street. That would just be cruel. Saw another builder online using HP switching supplies. He did not show how to attach the power supply wires and all HP supplies. I see online they do not have terminal lugs, but they have copper lands for connecting plugs to attach to it. I was very impressed with the amperage they are capable of. I took a lot of different things away from that one statement. This is another guy that is, quote, and I'm doing air quotes, is a builder. I'm not a technician, I'm a builder. It's in the name, Box Builder Idaho. Never claimed to be a technician of anything. I don't even know what that is. I know what an engineer is. I know what an RF engineer is. I don't have an engineering degree, so therefore it makes me a builder. I just build shit, and I build all kinds of stuff. That's the point. So anyhow, this other builder did not apparently watch both videos. First I did a video on how to modify these, and then I did another whole video on me actually testing them. You would be surprised how many people message me and says, yeah, but can you stack them together? And the answer to that question is yes. Let's spin the terminal strip, the output terminal strip around on this guy here. And let's take a look. As we can clearly see, we have our control tabs. Now the internet is full of breakout boards for these things, where you literally just plug them in. And it gives you a cute little screw attachment thing that allows you to hook up like 10 wires here and 10 wires there, and it breaks this entire board out. I don't know about you, I'm not going to spend the additional $15 on that breakout board when I can just solder right to the terminals. These are gold-plated landings. That is our positive lead, and it is also written on the board, 12 volt positive, it's right there. And these are our ground leads. It's also written on the board, right there, ground. To turn this power supply on, the days are over where we switch the 110 volt on by switching the 110 volt on the supply. These two things, this 100 amp supply and this 33 amp giant module, share some of the same characteristics. On this particular one, these three tabs are hot, these three tabs are ground. This is our case ground, that is our return neutral, or our other 110 volt line, and that's our other 110 volt line. So here's our 220 leads, our ground, our actual DC ground, and then our hot, and then our voltage adjustment. That's where the characteristics between these two stop. This is by far 100 times better than this. In cost value comparison, this is $30 for 30 amps, and it makes noise all over the place. It's very hard to work with, and you can't find one that's actually got the label on it that does what it's supposed to do. Versus $19, it takes 4 of these to equivalent the output power of this. So 4 times the amount of parts, 4 times the amount of real estate, 4 times the amount of cost. Well, 6 times the amount of cost. This is $25 to $30, this is $19. So like I said, 4 of these units times $40 a piece on the high end of things, or $19. 4 or 5 times the amount of cost, 4 or 5 times the parts, 4 or 5 times the energy. Okay. How we turn this on? The power supply can be plugged in. It's not going to pull a lick of current. It's off. All it knows is the 110 volts are here, present. This pin here and this pin here. You simply short them together. You don't, certain modules, like the 750 watt version, which is a completely different part number, not relevant to us, you have to add a resistor. This module, you do not. To turn it on, you simply put this leg and this leg and you tie them together with a micro switch, because there is no current really present. We're talking microamps, very little signal. This has got a 12 volt out landing on it and a return signal. Okay, so from here, you'll have the long lead, long lead, long lead, and that's your remote on. You take this terminal and switch it to this terminal, the power supply will turn on. All of these different strips do different things. The neatest bit out of the whole deal is a thing called load sharing. So now I've thoroughly said out loud, and I'm going to say it again. To turn the modules on, you tie this landing, this lead here, this trace, and this trace together with a switch. Power supply will turn on and run. That simple. Click on. So it's saving us money on contactors, it's saving us money on switches, it's saving us money on parts. This is so much easier than working with those 30 amp switchers. That's why I think it's so game-changing. I've literally just saved the entire radio community because I'm putting this out there for free. I don't want, need, desire anything from this. I'm simply putting this out there saying, here, this is an answer to our prayers. Let's all adopt it. This is going to be good. I have a very strong feeling that most of the builders in the United States are going to switch over to these switch modules. As soon as they sit down and they play, you're going to see that this little tiny module, which is the size of 3 packs of cigarettes, is going to completely take over the industry, which I think is great. It's an answer to prayer. And once again, this is as cool as going from the iron core linear supplies to the very first LED switch modules. We got drunk, stupid, sick on these cheap modules, because at the time they were relatively cheap. These are even cheaper and they do 4 times as much stuff. There's some really cool stuff we can do with these switch modules. And I'm telling you, I am not the one that knows everything about this in the whole universe. There is some guy out there that goes to sleep every night with one of these coddled up underneath his pillow. And he goes, oh, Supply, I love you. Oh, you're so sweet. Oh, your titties feel so good in my hand. Goes to sleep suckling on one of these. I am not that dude. I simply went out and looked around because I had a friend tell me about it. Thank you, by the way, Mr. 249. He put the buzz in my ear to go look at this. That's where the conversation stopped. He said, make sure you get the right module. So I bought 10 different modules on the market, sat down and played with them, figured out which one was, in my opinion, the easiest one to modify, and will work as close to this particular layout as we could get. I mean, the size difference between these things is just massive. And this thing produces 4 times the amount of current. Everybody's used to one thing, so we're going to slowly wean you over and switch you over to something better that works close to the same so nobody can be confused. This is a dual-sided board. So once again, ground, hot. You can run wires off both sides, which I strongly suggest we do. In certain these switch modules, a few of these tabs do a couple different things. But as far as everybody in the build community needs to know about, we're going to take and we're going to short out pin 1 and pin 4. You put them together, this unit will turn on. And we can stack these infinitely. Now, the funnest little bit that these supplies do, that the other ones do not, is this second tab. Tab 1, tab 2, tab 3, tab 4, tab 4, tab 1, tie them together, module turns on. This second tab, what it does is breathtaking. So, contrary to popular belief, we do not need to do any modification to make the fan run at idle. On some of the modules, to have the fan not be at full chooch, these little fans are amazing, absolutely amazing, but they're incredibly loud. When that fan kicks on, it's got 3 different stages to it. Okay, so like little jet engine, smaller, bigger jet engine, then massive jet engine. When they get to the jet engine phase, it's time to take the load away from this thing and let it go do its thing. If the module trips out, as in the indicator light on the back, which we're going to discuss here in a minute, goes out, that means it's gotten too hot and it's in safety protection mode. Just let the unit keep running until the fan slows down. When the fan slows down, that's when we cycle the thing, turn it on, turn it back off, or turn it off and then turn it back on, and a power supply will come back. In some of these modules, when you turn them on, that fan runs a full blast. Whee! And it'll drive you crazy. This particular style and model, once again, I've spent a lot of time thinking about this. This one particular style and model, we do not have to do anything to the outside or the inside to get it to where the fan self-regulates itself. This thing will sit here and just barely turn, and it's going to run almost whisper quiet. Here, I've got one set up over here. I just turned the power supply on. Can you hear it running? Turn the power supply off. Can you hear it running? The fan will do its own thing. You do not have to do any modifications to get the fan to do its job. Once this thing gets hot and starts getting too hot, then that fan's going to kick in and start doing its job. We do not want to mess with that. So I wanted to cover that as well. Okay, now back down here to talk about the second tab, the Miracle tab. So this trace right here, if we take and tie it to another power supply that's in the same circuit, there is a communication module that goes on between this unit and all the other units you'd be paralleling them with. And it does this thing called load sharing, which you can utilize or you don't have to utilize. You can leave it so it's just 100% on, and the power supply is sitting there waiting for something to be applied to it. Once again, to turn the unit on, we short this together and this together. Okay, this lead and this lead with a switch. I'll turn the power supply on. If you want to capitalize on the load sharing capabilities, which is really neat, which makes it an even more efficient power supply, when you start to stack up multiple units, let me grab a couple units so we can demonstrate this for everybody. Move this one out of the way. If we tie multiple units together, like this here, how we would tie these together is we would take ground and we'd take a wire and go from here down to this one, and another wire from here to this one. We'll take our ground and put it on this one, and our hot and put it on this one. And what that allows us to do, this goes out to the load and this goes out to the load. It allows us to pull evenly across both units. These have to be piggybacked or chained together. If we're going to do the remote on and not switch the 110 volt on and off, we tie this tab together, this tab together, the fourth tab in and the fourth tab in together on this, and use one switch, and both units will turn on. If you decide to do load sharing, which load sharing is, this thing is constantly looking for a load. And when it sees the load show up, it goes, okay, we're going to turn on this power supply. This one will stay in standby if this power supply doesn't get overloaded. This one will stay in standby. Once this unit senses that it's not going to be able to meet the power demands of whatever the load is that's being put to it, this one will turn on. And all you got to do is tie this wire and this wire together, and they automatically figure out what does what. All right. That alone, the load sharing thing alone, I'm going to capitalize a bunch on it on some future stuff that I've got going on. I saw that and my nippies got hard. Now, gentlemen, the other thing I want to point out is all breakout boards do not interchange between each module. If you don't have the breakout board specifically for this part number, the dps-1200sb, do not take another breakout board and slide it on here, because these pins do different things in different modules, and how you turn the modules on and off works completely different with other modules. Like I said, once again, there is a reason that I am saying by this module you're going to have the best success with it. Me personally feel that I've spent a few minutes in this hobby and a few minutes figuring out how people think in this hobby, and I'm telling you that this module with that part number is going to be the easiest for all of us to work with. On the back of each one of the modules, you have your on indicator light. Unlike this unit here, unlike that unit there, this LED right here is run off the power output of this strip. Okay? If you blow a module with one of these, you have no idea which one is dead until you pull each module and test each one of them individually. This is another huge advantage. I've had people come up with all kinds of cool ideas, like, man, you could put LEDs off each one of them, so if one goes down, you could indicator light, blah, 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 blah. That's what this little light does. If this thing turns on and is green, that means that the power supply is running and everything is good to go. It is not connected to these terminals. It is not. So if you chain a bunch of these together and you turn them on and you go and look at the indicator light, if that indicator light's not on, that means that module is bad. The old 30 amp modules, you tie them all together, If you had one module that was working, all the LEDs would light on all the modules. This has a separate indicator light. This is a hot swappable supply. Its original job was that they would take hundreds and hundreds and hundreds of these and put them into a server rack system, and a technician could walk by, a service technician could walk by and go, oh, this is the module that's dead. They'd have 100 of these in a row and they'd look for the green lights, green light, green light. Oh, this one's off. Okay. Click, grab a hold of this with one finger, like so, put pressure on this tab, slide this out of the rack, put another one back in it, and you'd be back up and running. And the light would come on and say, okay, we're good to go. That indicator light is another little thing I wanted to share with everybody. Okay, I think I've covered all of that. That answers 90% of the questions that I got yesterday via phone call, right there. Now, once again, I want to show this to you guys in full living color, so we can see that there's nothing going on here. This is 110 volt. The other thing is their auto switch. What I mean by that is right now this is currently wired on a 110 volt plug. I could put a 220 volt plug on this and I don't have to do anything with the module whatsoever to convert it from 110 volts to 220 volts. Just simply give it the 220 volts. The unit internally goes, oh, look, I got 220 volts. And it does everything internal. So, once again, that's an advantage that we have over these piles of garbage. So we don't have to flip the switch to tell it what voltage we're feeding it. It does it internally, automatic, with no energy or effort or anything from us on the outside, which I think is great. We can sell somebody a power supply or an amplifier with these modules in it. Well, it's a 110 or 220. So whatever you want to hook up to it, the module will figure it out. The only limitation is that the 110 volt coming out the wall is only good for about 200 amps. Anything over that, we have to be 220. So how do we cover our butts on that? We just put a sticker on a freaking power supply. Let's go in here. Once again, how do we turn the module on? Simple, with a simple switch. Power supply on. Power supply off. Ready? We'll do that again. Power supply off, flick the switch, power supply on. Power supply off, power supply on. If you watch this video and you watch the other video, the actual how to hack this module, how to adjust the voltage and make it so it goes over 15.8, you will be able to use these things just as well as everybody else. Okay. Gentlemen, on that note, I'm going to run away. I want to give a big shout out to my Patreons for all their support. I'm going to say thank you, Penna Labs, for your support, XS, Siglant, McMahon Bird, Coaxial Dynamics. Thank you, guys. And a big thanks to all of you. Hopefully this helps. On to the next project. I'll see you. Click, click.